Hello, travelers. Welcome to Reach the World's Explorer program. For over 20 years, Reach the World has inspired youth to become curious, confident, and compassionate global citizens through virtual exchange. My name is Tim, and I'm so glad you're joining us for today's live stream event. What lies in the darkest, most remote depths of our oceans? How can we use incredible underwater robotics and technology to explore these places that inspire so much curiosity? Those are the questions at the center of Reach the World's virtual exchange expedition with members of the Ocean Infinity team. Today, we're talking with Ocean Infinity engineer Charlotte Ekins. Charlotte is helping to design and build the world's first fleet of self-driving ocean ships. She's joining us to talk about this amazing project and to answer all your questions about marine robotics and engineering. Excuse me. If you haven't already read Charlotte's article about her work, I highly recommend it. We'll add the link in the YouTube chat bar on the right-hand side of your screen. If you're just joining us and you want to reserve your classroom's place for the duration of this virtual exchange, we'd love to have you, and we'll add the registration link to the chat bar as well. I wanted to give a special welcome to the teachers and students who are joining us live today. Please feel free to use the YouTube chat bar to let us know you're here, where you're joining from, and of course to share any questions you have for Charlotte as we go. I can't wait to ask her some myself. We'll get to as many questions as we can in the next 30 minutes or so. And without any further delay, it's time to unlock the ocean's secrets. Charlotte, welcome to Reach the World.
Thanks, Tim. Oh, awesome. What an introduction. I am really excited to be here with you all, and I'm most excited for your questions later. So I'm hoping to speak to you about some things that are going to provoke some questions, stir up some new ideas in your minds. Let me start by sharing my screen with you. So let me introduce myself. My name is Charlotte Ekins. I have worked with Ocean Infinity for coming about 8 months now. This is my first job out of university, and to be honest, it's a pretty cool job to have. I didn't think when I started studying 4 years ago that I would end up where I am today. It's been a path. So let's start with what we're going to be going through today. Tim, is that okay? Can you see that changing?
Yeah, looks great, Charlotte. Thanks.
Awesome. Okay, so we're going to start off with how I got here, how I became an engineer at Ocean Infinity. And then I'm going to start talking about the big project that we're working on that hopefully you guys have heard some hints and tips about what it is, and it's piques of interest. So let's start with when I was your age. So I came to engineering because I really loved science and maths. Solving puzzles, doing jigsaw and Lego when I was a kid, and I just like to fix things. And so then when I was 18 years old, I decided to go to university to study engineering. And I did a type of engineering called mechanical, so it's very broad type of engineering. And it took me 4 years to study, and my degree looked a bit like this. So there was a lot of maths, a lot of diagrams, a lot of science, a lot of robotics. I'm going to give you a second to try and guess what the thing in the middle is. It's a test rig that we were using to fast charge a battery pack that we made in my third year of university. That they actually let us build a battery pack from scratch and put it on the back of a bicycle to send it down the road and make an electric bicycle, which was a lot of fun. Pretty dangerous, but a lot of fun. So after 4 years of studying, this was in London, a university called Imperial College, which does a lot of science and technology. I then made a big move to the south coast of the UK, which I wasn't expecting. So you can see from the map on the top right-hand corner, it's kind of 85 miles away from where I lived in London, the picture on the left. Can you guys spot Big Ben in that picture? So I love living in London, being in a busy city. That's where all my friends lived. But this job at Ocean Infinity came along, where we were building the first fleet of uncrewed robotic ships. I just couldn't say no to that as an opportunity. So I wanted to encourage you all, if you ever get the chance to move cities, move countries for a job, for a new experience. It's worth it. You never know what's going to happen. So this one is what I actually got up to last weekend. So I'm going to give you a second to guess from the two pictures on the right what I was up to. Hopefully some of you might have given it a go in the past. So I'm a rock climber in my spare time. I love cycling, climbing, hiking, anything that's outdoorsy. So that's what I did this weekend, a bit about me. And the main thing that I want to speak to you guys about is the project. So we are designing a fleet of uncrewed robotic ships. We're not just building one, we're not just building two, we're building 17 of them, all in one go, all of different sizes, from 8 meters to 78 meters, which is pretty big, pretty huge. And they're different sizes because they all do different jobs. They've all got different bits of equipment on them. They do different bits of work for us. And I'm going to jump ahead to what we used to do. So you guys might have heard a bit from some of my colleagues about the big ships that we have. We've only got one at the moment. We used to have 3, and they're even bigger. They're 100 meters in size. So ours are, we'll jump back. Our biggest one is 78, so they're a bit smaller. But all of these ships have nobody on them. The plan in the fullness of time is to have no crew on them whatsoever. Whereas our big ships, they have 50 people on them as an average, and maybe 21 of them are the main crew. So they keep things going, like the engines, they steer the vessel, they do the cooking, they do the cleaning, and the rest of them are all the people who work like me for Ocean Infinity. And we do all of our survey work, which you guys will hopefully heard a little bit about with the ROVs and the AUVs. Okay, so I'm trying to draw a comparison between how you operate our boats. So if you imagine that our boats are a bit like a drone, hopefully some of you guys might have had the chance to fly a drone or have seen them on TV. So you have a hand controller, and you kind of say, go left, go right, go faster, go slower. And the way that you control a drone like that is pretty much how we're controlling our boats, but a bit more complicated, I guess. So we've got the person who's controlling it sits somewhere, and then the ship or the drone is very far away, doing what you send the commands to it. So I said very far away, but that's pretty a broad term. So our crew for the ship, there won't be 51 of them. We're gonna, because we're not gonna need to do the cleaning, we're not gonna need to do the cooking. It's gonna be just the people kind of operating the ship, steering it, and they will sit in these control centers, like these 2 pictures on the right-hand side. And you can see they're pretty similar to the picture on the left, which is what it looks like on our big ships. So this picture on the left, if I jump back to here, too far back, one more. So on our big ships here, you can imagine we've got 50 people on this vessel. And Tim, can you see my mouse on screen?
Yes. Cool.
So this room here is called the bridge of the ship. And here you can look out and you can see a whole 360-degree view of the ocean. You can see all the ships on the horizon that you might be sailing past. You might be going to collide with them. You might need to slightly alter your course to go around them. And it's really important to be able to see everything clearly. So we're going to try and do the same setup for our ships. So here we've got these huge screens, like the biggest screen that I've ever seen in my life. You sit there and it's overwhelming. You can barely take it all in. And that's going to have the this 360-degree video. So it looks like you're on the sea. You feel like you're on the sea. You're sat in this big control chair. It feels a bit like you're playing a video game in a really cool way. So these are called our remote control centers. And they're going to be operated by the people that are used to operating the ships, like this picture on the left-hand side. So 17 ships, that's going to need a lot of control centers, a lot of these bridges. So the picture on the left is what this control room looked like when it was empty. And it's as big as a warehouse, as big as a supermarket, really tall ceilings. We've already filled it. You can see this picture on the bottom right. I think I took this one last week from our build site. So the project isn't done yet. We haven't built these ships. They're still being built, still being tested. And you can see all around the outside of the room, we're going to have all of these bridges, and each one will control a different ship, or we might have a few that control one ship. We don't know yet because we haven't done it. This is part of the fun of doing something brand new. We'll figure it out as we go along. And then we'll have people that stand in the middle, and they kind of help support all of the ships from the outside. There'll be lots of glass, it'll be a big spacious room, but it looks very different to the bridge of a ship when you look at it from the outside, and then you zoom in and you go back to these little pods, and it feels like the bridge of a ship again. And the people who are used to being at sea, they'll feel at home and be able to carry out their job. So if we jump back to how we're going to control the ship, if you imagine how far a drone is away from the controller, you might be only in the same field. It's pretty close range, and you control it using Bluetooth, which is how you control your phone to your speakers, or your phone to your laptop, how they talk to each other. So that works really well, but it only works over short ranges. But our boats are going to be the other side of the ocean. They're going to be the other side of the world. So we need to control them in a different way. So some of you guys might have seen this picture before because it was in one of my articles that I sent to Reach the World. So we're going to control our ships using satellite, which is satellites work using radio waves. Radio waves are pretty cool. So have a chat with your teacher, look them up. They let us do a lot of really vital things in our society. So we're going to be here on the right-hand side in the UK, and we're going to use satellites to talk to our vessels in the middle of the ocean, and also to communicate with our other control centers. We'd like to have one in the US, we'd like to have one in Singapore, so that we can communicate with our vessels, so that someone around the world, it's always daylight. We can operate 24 hours a day. So the other thing that we're doing very globally is where we're building our ships. So if we have a look at this map, forgive me because I put England in the middle of this map, not the US. So this is where I am on the south coast of the UK. And then in the US, we have an office in Austin. And there's engineers just like me working over there. We've got some other parts of our vessel being built and tested in Delaware. And our big ships, the hulls of the ship, so that's the outer part of it, that helps the vessel float. If you took everything off the vessel, that would just be the outer skin of it. It's called the hull. And those are very complicated and specialist pieces of material, because they go very fast through the water, and they float, and they have to be very maneuverable. So they've been designed and built. We've got some being built in Norway and some being built in Vietnam. So it's interesting how we're going to get them to us. We might be able to sail the ones from Norway down to us, or it might be that we fly them down, or we might even take them on a train. But this is part of the exciting thing of being a global company. And these pictures are what those different shipyards look like. So this is my local one. This is near me in Southampton. My office is in part of this warehouse. You get to work right on the waterfront here. And some of my colleagues, so for example, my colleague John is working in Norway and he gets to go skiing on the weekend. He gets snowed in some days. And then we're going to soon have colleagues in Vietnam where our bigger boats are being built, the 78 meters. So this is a few more pictures about what our offices look like. So we have a few in Southampton. This is one of our different offices in Southampton, which is where those remote control centres are being built. And to build robot vessels, you need a few different things. One of them is near water, so you can launch your vessels and work on them. And one of them is a lot of space. So this is how big the building is. And if you imagine 2/3 of it, or this bit on the left-hand side, that's all going to be empty space for building the vessel and operating them. It's only this tiny bit over here that's going to be office space. And these pictures on the bottom, I guess, is what my day-to-day looks like, full of tools and cool electronic gear and testing it out. So it's really important to test everything before we put it onto the vessel. If you take 5 components and it works on its own, then you want to individually match them all up so that they all work together. There's no point spending loads of time putting it all together and being like, oh, it doesn't work. What are we going to do now? So it's really important you test everything individually before we put it all together in one big boat. Okay, I'm going to take a step back and just kind of talk to you about what it feels like to be an engineer, what I go through on a daily basis. So if we have a think about a mug and how you design a mug. So I think of engineers as problem solvers. There's the design phase, the make phase, and the test phase. So you might take a mug and you say, this mug isn't good enough. I need something that is a bit bigger so I can put a bit more tea in it, a bit more coffee. So you think, do I want it a bit bigger in this way? Do I want it a bit bigger in this way? Do I want the handle to be a bit bigger? I need to be able to hold it. It needs to be strong. It needs to be able to keep my hands cool when I put something hot in it. So that's all about designing it and having a think about the requirements. The next thing is I need to make it. So you have a think about where you're going to make it. What material will it be made of? Are you going to make it yourself, or are you going to pay someone to make it for you? These are all the design problems and questions that we do on a daily basis. And then the last thing is I'm going to test it. So one of the things that I might test it for is I might put some hot water in it and see how cool my hands stay on the outside of it, like a safety test. I might test it to see how easily it smashes. Like the destructive testings are always the best ones. When you get to smash things, you get to use things above and beyond what they're meant to do. So like with that battery pack that I showed, one of the tests that we did is we tried to explode the battery pack by charging it, putting loads and loads of electricity in it. We haven't got around to any of those with our boats yet. We're still a bit earlier on. So enough talking about mugs, let's talk about something to do with the boats. So one of the problems that I worked on recently was thinking about those control chairs in the remote control centres and thinking, how are we going to mount the touch screens that the bridge operator will interact with? Okay, this is a bit of an overwhelming diagram, but I think it's really cool, and so I wanted to share it all with you. So the word anthropometrics is a difficult one to say, so I want to challenge you all to say it. But it's really interesting because it's the study of how a human interacts with the world around them. If you think about how someone who's a bit taller than you or a bit shorter than you, how will they sit in a chair? Will they be a bit higher up? Will they be a bit lower down? How far away do they need to be away from the screen? And how close do they need to be? So it's all about taking an average of the population and finding a comfortable position for that person, and then designing around that. There's no point designing something that is then really difficult to use. So the problem that I had to look at, how we mount these touch screens, involved anthropometrics and a few other factors. So if we jump back, like we did with the mug, to the 3 different phases of engineering, if we have a think about the design phase here on the left, if you take this picture in isolation, if you kind of cover up the whole screen and look at just this first picture, I don't think you'd be able to guess what it is. But then you put it in context with the picture to the right of it, and it suddenly makes sense. It's a mount for a screen, and it's such a funky shape, so that the screen is the perfect angle towards the person, and it's a perfect distance away that they can reach it comfortably. So that was one of the things I did. I took the design, the dimensions of where we wanted the screen to be, and I put it in a 3D model on my computer, which is something I do a lot of. So that's what these 2 images are. They're from a 3D model. It's called computer aided design. And there's lots of free packages that you can have a go at. So if it's something you're interested in, then please ask a question about it. So the next thing we did is we wanted to make it to see what it looked like in real life. So we 3D printed it. This is a pretty cool 3D printer because it's pretty big. Some of you guys might have seen small ones that kind of sit on your desk and you make little components from them. This screen mount was about 30 centimeters long. So we needed quite a big 3D printer. So we made it out of plastic. And the picture on the right-hand side is me testing it. The thing about making it out of plastic is that it's not very strong. So quite quickly, the next picture of this should have been the screen snapping in half. And we just had enough time to take the monitor off the top of it. But that's okay, because this was a test. The idea was to understand if we got the positioning right. It didn't matter how strong it was. It only mattered if we got the position right. So we did the design, the make, and the test. And the next thing to do was to go all the way back to the beginning. We tweaked a few things. We actually moved a few of these holes so that the screen was a little bit higher up. And then we made it again, but this time we made it out of metal, out of aluminium, so it was a lot stronger. And we didn't do that the first time because it's more expensive. So we wanted to do the cheaper option first, get the design right, and then go again. So that's being built at the moment. And the next test will be to sit there with the screen, to use it to put a lot of force on it, to really press the screen quite hard and check that we're happy with it. And once we've checked we're happy with that, then we can make not just one, but we can make 40 for all of the bridges. So that was all I wanted to share with you for now, but I've got loads more pictures here and we've got time for questions. So I'm going to open it up to Tim.
Thank you, Charlotte. Let me share a couple questions on behalf of our students quick, and then I'd love to see some of the other pictures you have too, because I could listen to you speak about this all day long, and I think a lot of our students could as well. I'm really glad you brought up sort of how you got into this job and this career, because so many of us love Lego and puzzles and those things that you think of as games, but really have real life application. And it's really cool to see you taking those skills and obviously developing them in a university setting and doing something really neat with them. Do you have any other things that students who are really into this or would like to be you someday, would like to be doing what you're doing, anything you'd recommend that they study or pursue or check out now so they can start down that path?
Oh yeah, I think these are really awesome things to be into, and the great thing is you can do them in school or you can do them outside of school. So in school, it's really important, if you want to be an engineer in the future, to keep working hard in maths and in sciences. But don't worry if you're not, if you don't like those kind of like really academic subjects, because some engineers they really like doing maths like me, and some engineers really like the practical work. So you could just really like fixing things at home, and you can really like doing art and design, and you could be that type of engineer. You can maybe do something called an apprenticeship, which is more practical. The great thing is that there's also loads of free stuff online. If you want to try a bit of coding, or you want to try a bit of robotics, then you can do those sort of things online, or maybe in school. So yeah, Tim, that's my recommendation.
All right, great. Thank you so much. It's a kind of an obvious question I'd like to ask on behalf of our students too. When you're thinking about a ship that doesn't have crew, we had a chance to speak with one of your colleagues and get a tour of the Island Pride, Ocean Infinity's big research vessel. And we saw all the cafeteria space, all the bedrooms, all the space you need for people when there are people on board. Do you just have a whole bunch of extra room to deal with on a ship that doesn't need people?
Oh, we've quickly filled all the room. Don't worry, there's no space left on our ships. They are packed. So yeah, you need less people on these ships. You're taking off all the people that help. One of the guys on the ships described to me the other day, it's like being in a hotel in a really nice way. You're really well looked after. And all of those people just come back onto land. And the space that was the kitchens and was the crew hangout rooms, we've just put more robotic gear on that. We've put so we can do our jobs better. We gather a lot of survey data. That's our business. So we can do that. But a cool thing we're doing on our 78-meter vessels is we're being more sustainable. So a big bit of the ship is now taken up with a big tank that we're going to fill with ammonia. And you guys might have heard before that ammonia is a chemical that you can produce hydrogen from. And so the ships will be powered by hydrogen rather than fuel like diesel or oil like hydrocarbons. And it's much more sustainable. When you burn hydrocarbons, this is a bit of chemistry, the only thing that you get out of it is water and energy. So you don't get all of the CO2, the chemicals that can be bad for our environment. So that's why we've gone for that decision. And that takes up a lot of space. And thankfully we have that space now.
I'm glad you brought up the environmental impact, because that seems like a really revolutionary step in terms of how we operate on oceans, being able to not use as much crude oil and some of the, I think it's called bunker, the really bad stuff that ships burn. Yeah.
And one of the really interesting things that I wouldn't have thought about, because I never was in the marine sector until I joined this company, is that we actually spend a lot of fuel flying our crew around the world. From the UK, I have colleagues who just launched from California, and when we flew them to California, they had to get an American visa, and then they all went from there, and then they went down to the Pacific Ocean, and that burnt a lot of hydrocarbons, a lot of oil on that flight. And if that crew could stay in Southampton and operate the ship from here, then think how much less fuel we're burning.
Yeah, that's amazing. It's great to hear about that too. You talked about being able to send these ships really anywhere on the world's oceans, which is very exciting because there are a lot of places right now that are really hard to reach, or at least hard to stay at for extended periods of time. Are there any areas of the world that are especially challenging for you as you think about sending a ship with no in-person crew on it?
Yeah. Oh, this is exciting. So this is a bit of a tricky question for me because I've never worked at sea. So I'm going to talk about it from some of the design challenges that I've had to work with whilst designing the vessels. If you think about how far north or how far south you have to go, it gets a lot colder. So one of the things that we're doing for some of our ships is making them ice class. So they have a really strong front part of the ship so that they can break through and crack the ice. And they also have a lot of insulation, which then keeps everything inside, all the computers, all of the electronic equipment, a good temperature and protects it from the really cold extremes. But this takes a lot more engineering, a lot more designing, makes our boats a lot heavier. So it's really important to think, do we really need to go this far north, this far south to design that? And then conversely, we want to be able to work in really hot environments right around the equator up to, I mean, so I work in degrees C, so I do 45 degrees C. Tim, off the top of your head, do you know what that is in Fahrenheit?
Not precisely, but I think definitely over 100 degrees Fahrenheit.
Okay, so yeah, just really hot. And so to be able to design something that is within its life is going to work in such hot and such cold temperatures is really challenging. And the final thing about where in the world we're going to operate it is our ships are designed to be operated 24 hours a day. You're not going to leave a ship at anchor in the middle of an ocean somewhere just because your crew needs to sleep. That is not cost effective. That's not safe to do as well, because you need to be alert at all times when you're on the vessel. So what they do if you're on the vessel is you'd have shift patterns. Some people would be awake, some people would be asleep. And we're going to try and do the same thing when we're on land. But like I was trying to say earlier, it makes perfect sense if you think of the world to have a control center here, and then a third the way around the world to have another one, and then another one, so that everyone is just working in the day all the time and they can live a normal life and sleep at night.
Yeah, that's fascinating. It really changes the concept of what a ship captain is too.
Definitely.
Well, fascinating. Those were some of our most pressing questions for you. I would love to see sort of the rest of the photos that you had to show us, if you wouldn't mind.
Yeah, sure. Let me jump back. Okay. Tim, shout when you can see the slides again.
Yep, looks good.
Okay. So the next thing I wanted to show you guys is, again, how we do engineering in the design, make, and the test, but in terms of the ship's hull. So this is the skin of the ship, the bit that needs to be really strong to break through the ice, but it needs to be able to float in the water. And so we design it again in a 3D model. So you can see this top picture. This is a side view of what our ship looks like. So you've got all of the electronic equipment at the top. So this is all the radio equipment that will communicate with our satellites. These big domes, they have radio equipment in them, and then we have some at the top of the mast. You've got the vessel itself, and then underneath we have everything that powers the vessel. So we've got the engine room here with the big generators, like the engine in your car. And then at the back, it's got a propeller that spins and it powers the boat to go forward. And you've got a rudder, which is how we steer the vessel. We turn it left and right. So we do 3D modeling, computer-aided design to design what the vessel is going to look like and what shape it's going to be, and then we build it. So the build, I like to think of engineering a bit like a jigsaw puzzle. So what you do is you cut out the pieces. This is made of aluminium. So aluminium is a great metal because it's really light and it's really strong, and it's kind of flexible. So it's ridged like this to make it even stronger, and then it's welded together. So this is not one of our welders, but I wanted to show you guys, if you hadn't heard of welding before, it's when you heat up the metal really, really hot so that it melts, it becomes liquid, and then you can stick one bit to the other, just like you're super gluing them together. And it looks a bit like this. You can see this is one of our 21-meter vessels, and you can see where it's kind of stuck together with all these bits of weld, all these bits of glue. Tim, shall I keep going?
Yes, please.
Okay. Yeah, the other thing I wanted to show you guys is the cool terminology that you think about in the marine sector. So we don't go for left and right, we go for port and starboard. And the other thing I wanted to show you was kind of the depths that some of our kit goes to. So if you think about our remotely operated vehicles, some of them go to about 600 meters deep, but some of our other bits of equipment that my colleagues have spoken to you about, some of the other ROVs or our AUVs, autonomous underwater vehicles and remotely operated vehicles, they go to 6,000 meters. below the ocean surface, which is really, really deep. And so to be able to design something that withstands all that pressure takes a huge amount of engineering. I'm just going to flick through and see what else I wanted to show you guys. I'm going to jump to this one. So this is our smallest autonomous uncrewed vessel. So this one is really small. It's only 8 meters on size. I'm not sure you could fit a person on it, even if you really wanted to. I don't know where they'd sit. So for scale, here's one of them. We've got a, sorry, this isn't one of them. This is about how big they are. This is a different yellow boat, but it's a similar size. So you see how big a person is in comparison to it. And they sit on the deck of our ship like this, and they're launched off the side. They kind of float along the water with like a mothership in the center. So we've got like the same as we spoke about just now. We've got all the power in the back, the engine, like in your car, and that propels it forward. And then we've got all this equipment on top that does the radio waves and communicates with us. So much cool engineering all in one boat. But we're not sticking with 8 meters. We've got something a bit bigger. This is our 21 meter vessel. So again, these are just some more, I just showed this one to you, but these are just some more pictures of what it looks like in 3D. So huge amount of equipment on top, and then a flat deck, which we're filling with loads of robotic equipment on top of it, that does all of our daily work, our survey work. I think, Tim, that's all I'm going to share with you.
Sure. Yeah, great. Charlotte, that is amazing. What a great example of really practical problem solving to, accomplish something that has never been done before, really get to some of these places in the ocean that we know so little about. It's really neat to hear you talk about how that's being done right now, and how future engineers and young people who are excited about careers in the ocean and careers in STEM fields can get involved if that's something they want to do. So I really appreciate you joining us today, Charlotte. It's been a lot of fun talking to you and hearing from you. I want to thank also our entire on camera and YouTube live stream audience for the great questions. We have a couple more Ocean Infinity special guests to come. We're really getting the full picture of what's going on at the cutting edge of marine robotics. So we have a couple more topics to cover though, and I want to make sure anybody who wants to join us, let you know you're very welcome. I've included the link to Charlotte's article in the chat bar on the YouTube chat area. So if you haven't already read it, you can hear some more from her and see some of these great pictures that she's shown us today. Don't miss a single article or video call with the Ocean Infinity team. We've got a couple more weeks to go, like I said, and for a complete listing of upcoming Reach the World events, you can visit athome.reachtheworld.org. Charlotte, thank you so much, and we'll see you next time.
Thanks, Tim. Bye, everyone.